Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's say today's problem, find pair given difference. So what the problem is saying is we'll be given an array of size n and an integer x. Return 1 if there exists a pair of elements in the array whose absolute difference is x. Otherwise return -1. Okay. And we want to solve this problem in O of n log n. Okay. And space, this is time complexity and space complexity is O of 1. Okay. So what the x will be, let's see an example, right? X in this case is 78. So what we want to do is we want to find So we want to find a pair, right? So is there any pair in this array? So here, if you see, we have a pair whose absolute difference is 78, right? So we want to return 1 in this case. If the pair does not exist, then we want to return -1. Okay. So how can we solve this problem? Okay. So one brute force solution can be to have two for loops. For example, for I equal to 0 to n-1 and j equal to, sorry, I plus 1 to n. Okay. And simply we want to check for a of, or maybe absolute, right? A of j minus a of I. If it is equal to x, then simply return 1, right? Else return, if there does not exist a pair, we have to return -1, right? Outside the two formulas. Okay. So this will be the brute force solution. What will be the time complexity for this? O of n square, right? So we want to optimize this further, as the expected time complexity is O of n log n and the space complexity is O of 1. Okay. So what we can do, right? So if you see at the time complexity, right? So it is hinting something. So when do we get n log n? So generally when we sort the array or sort, right? When there is sorting involved, we get n log n, right? So we'll sort this array. Okay. So what will be the sorted elements? 2, 3, 5. Okay, 5, 20, and 80. Okay. Okay. So here we have sorted element. So sorted elements. Okay. And what we're going to do is we want to use the two pointer technique. Okay, to solve this problem. So we'll have two pointers I and j. Okay. And what we're going to do? Let me also add the pseudo code. While I is less than n and n. Definitely we have to quote in. Then I is less than n and then j is less than n. Okay. So what we're going to do? We're going to check again here. If absolute difference of a of j minus a of I, right? I think absolute is not required here. If it is equal to x, right? Because a of j is definitely going to be greater than a of I. Right? So here, right? So what we're saying, if it is equal to x, then simply return 1. Okay. Now here in this case, what is the case here? What is the case here? Yeah, the difference is 1, right? Which is not equal to x, right? But which is lesser than 78. So what we want to do? We want to have bigger difference, right? The difference here is 1. So what we're going to do? We are going to increment j, right? We are going to increment j. So now again, so here we'll write the condition accordingly. Else if a of j minus a of I, right? If it is less than x, then we want to have a bigger difference, right? The difference is small, so we want to increment j. We want to go towards I. We want to increment j, right? Else what we'll do? Else what we'll do? Else we will increment I. That is when, sorry, that is when the difference is more, right? The difference is more greater than x, then we are going to increment I. Okay. And j will be there as is. Okay. If we increment I, definitely the difference is going to be smaller. That is why we are incrementing I here. So what you're doing here is, yeah, again. So j is here and 2 is here. I is here, right? So what is the difference again? The difference is 3. Okay, which is again lesser than our x value, right? So we are again going to increment j, right? Going to have bigger difference, right? So here 5 minus 2 again, it's the same. We'll increment j again, right? So 20 minus 2, it's 18. The difference is increased, but it is still lesser than x, right? So we'll again increment j, and here it is 80 minus 2, right? Which is giving us 78. So we have found the difference here. We are going to return 1, right? So this is the pseudocode for this, right? And else, like this condition, this example did not cover this case, but yes. So when the difference is greater than x, then we want to increment I, right? And we'll keep j as is. Now, if we increment I, definitely we'll get a bigger number, hence the difference will be smaller, right? So that's what we want to do, right? We want to go towards x, okay? Okay. So yeah, so this is pseudocode. Okay, I hope you've got the intuition when solving the problem. I would request you to subscribe to my channel before going to the code. So now I'm going to implement Java code. Okay, followed by C++. I'll show you the C++ code as well. Okay, so let's quickly sort the array. Now we'll have a for loop. So what are we going to do? If array of j minus r of I, right? If it is equal to x, then simply return 1. Else if r of j is greater than, sorry, the difference, if it is greater than x, right? If it is smaller than x, sorry, then we want to increment j, right? As to go towards x, right? To go towards x, right? Else increment I. So when we are incrementing I, when the difference is more than x, right? Then we want to increment I, right? So yes, so and finally, then minus 1. So let me compile this. Sitting longer. I am bad. Int I equal to 0, int j equal to 0, j equal to submitted. Okay. So yes, the test cases have been accepted. Thanks for watching. Please subscribe to my channel. Let's quickly see the C++ code as well. Okay, so here is the C++ code sorting. We are sorting the array, the vector, and we are having these two variables. The same, the code is same, right? So here, right? So here we are checking if it is the same, right? If the difference is x, then return 1. Else, if the difference is less, increment j. If the difference is more, increment I, right? That's what we're doing here. So yeah, let me submit it. Thanks for watching. Please subscribe to my channel. Have a happy, healthy, and a peaceful day. Thank you so much.